Stomp Rocket problem. A child stomps on a stomp rocket. It's probably how it got its name. Or a physics student. This is a great lab to do in September. The rocket goes in the air, so that it returns to the ground in 3.2 seconds. What was the stomp rocket's initial velocity and maximum height? First of all, this is unbelievably cool. Just by measuring the time it takes for this rocket to go up and come back down, you can calculate its initial velocity and how high it went. That's neat. Okay, so we're going to sketch this out just so we can label different points. The rocket goes up, it comes down. You really want it to go straight up and down, as close as you can. Okay, you don't want any sideways velocity because the rocket won't go as high as it should. But don't worry about that at this level. Just try and get it to go straight up. Our initial conditions, x0 is equal to 0. It starts on the ground. The initial velocity, that's what we want to find. At the top, we've already spoken about this. The velocity at the top is 0, right? Because it's moving in the positive direction. Then when it comes down, it goes negative. So how do you get from positive to negative number? You have to go through 0. So the velocity is 0 at the top. Now, what did we do that was tricky here? We know that the total time is 3.2 seconds. We said it's going to take the same amount of time going up and coming down. So we're going to say the time at the top is 1.6 seconds, and we'll find that x position. Okay, so what are we doing here? Why did we do that? Well, we don't know the velocity of the rocket when it hits the ground, so our final location should be the apex. That's a fancy word for the top of the trajectory. So that's why we're dealing all up here. And you know what? Way too much stuff written there, so let me erase some of that. The key part of this experiment is we know the velocity here. We do not know the velocity here. Therefore, we want to work with the top part of the problem. So if it took 3.2 seconds to come down, we're going to assume it took half the time to get up and the other half to come down. What else do we know? We also know that the acceleration that this experiences is negative 9.8 meters per second squared at every point in the trajectory. And just emphasizing the point again, we know information about the top of our trajectory. At the bottom, we just know the time. So by saying it takes half the time to get up, half to come down, we now know the time up here, it's 1.6 seconds, and we also know the velocity, it's 0. So now we can list all our criteria here. So we knew a lot more than we did than just the 3.2 seconds. Select an appropriate equation to use. So here's our variables and our constant. We'll ignore the height question for now and solve for v0 first. The correct equation will be this one. We have v, x0, t, and a listed as variables, and we need to solve for v0. There is no mention of x for the first part of this problem. So let's see, what do we have? We have v, okay, we'd like to find v0. We have a, that's negative 9.8, and we have t, which is 1.6 seconds, which is half the time of the total flight. Here we are with the first kinematics equation. We know that v is equal to 0, so we replace v with 0, and then we have v0 plus at on the right. We want v0 all by itself, so we add a negative at to both sides. We get negative at on the left, v0 all by itself on the right, and then we just switch them around, so v0 is minus at. Once again, maybe you're worried that the initial velocity is minus at, because that means it's going down, and you know that you shot the rocket up in the air. But let's trust in our math, and we have v0 is minus, and then what's a? A is a negative 9.8 meters per second. It's in the down direction. That's good, so the two negatives will cancel out, multiply through by the time, and we get 15.7 meters per second. And we rounded that to 3 digits. Now we'll return to the second part of the problem where we wanted to find the height. We can now use the initial velocity that we calculated, and we can use either of the remaining kinematics equations, either 2 or 3, to find the height x. It's easier to use the first one since it is already solved for x. Now we can put in our numbers. We've already solved for it algebraically. Actually, we just had to use the equation, which is great. So what do we plug in? Initial height is 0. Here's our initial velocity that we solved for in the first part of the problem. Here's our time. Then over here, here's a negative 9.8. And there's a half there, don't forget that. And then here's t what? It's t squared. Do not forget to square that term. So we have one time here that's not squared and a time squared over here. Put in the numbers and we get 12.576 meters, but our rule is we just take 3 digits. I mean, that's our rule. It's not a big thing, but again, we're more interested in you knowing the physics here than worrying about significant figures. So it's 12.6 meters.